So first of all, let's just keep things clean in here. So we flip the curves, got the polylines, and this was really all about, let's just grab those last components and scribble set up panel planes. And the last step here was that we got the planes for each panel. Now the nice thing is here we can start to think about, oh, we've got that rotation system, because we can use the axis. So this is those lines through there. Let's just hide these ones, we're not so interested in those. That's those lines. So we've got a rotation axis that we can use, and we've got planes to orientate some kind of geometry. But first of all, let's just have a look very quickly at if we want to make a simple rectangle based on that plane. And here the rectangle, its dimensions are defined by domains. So construct domain. So here I'm going to set the a value to be negative, so minus x. And this is going to be, let's try 900. So I can connect that to both of these. So that gives me a range minus 900 to 900. And so we said this was the x direction, so this should be in the y direction. So there you go, you can see there's a very skinny panel. And now if we copy that, just plug it in here, we'll get a nice square orientated for each panel. And we want to set the length of that in relation to these lines, so we can check length. Wait, no, not divide length, we want length of line, and we want to divide that by 2, so division A divided by set. It's just outside the screen, so I'll just shift that. So set data item, I'm just going to put the 2 directly in there just to keep the model nice and clean. I've copied that domain because it's got the expression that just flips it over. So now each panel has got its own specific width. You can see here we get a bit of a clash. So let's make this subtract, and let's put in, this is our 50mm tolerance. Put those back in there. So maybe it should be a bit more than 50, that looks a little bit close. So the idea is we've got a kind of rational system here. You know, this can be increased, there's some overlap. So there we've got individual panels set up for each one, and we can see them, we can visualize them if we use the surface, this one here, boundary surfaces, and we can see each of those panels through there. And then if we want to apply some rotation to that, that's just to visualize it really right there, we can do rotate an object around an axis. That's the object we're going to rotate. That's the angle right now, and this is the axis. So our axis here, these lines, and so now that's the more rotated at 90 degrees. This isn't really about the control of that angle. It's probably for another time. So let's just leave that with a fairly small angle. So let's just leave it at maybe 10 degrees for now. And we need to convert that to radians. somewhat too small. Let's try just changing that. I think the minimum, maybe it should be negative. Okay. Yeah, so that's looking like they're under control. So again, we just need to tidy this up a little bit here. And that as a group with a note. Define and rotate panels. Add that to the group, so keep it together. This is just to visualize it really for now. So yeah, there we got the paneling system, and obviously we can go back and shift our list around. Stays nice and lightweight, and you can see if we go to the other side, let's see what happens here. We're going to get some issues. Actually, that seems to be even working okay on this side, so we can we can use this system to define our panels wherever we want, although some of those panels look slightly over rotated. So perhaps it's worth just looking at how we'd actually begin to develop more detail related to the panel. Actually, I think it's probably better to, rather than rotate the rectangle, we can just rotate our reference planes. Obviously the boundary doesn't work because we need to build the rectangle on those planes. And once we've got the plane there, we can do all kinds of useful things with it. So we can say, if maybe we need to offset our panels, so we can just directly do move. We're going to move the panels in relation to the plane. Okay, so what we can do is, if we do unit, that's actually going to give us one vector per plane, which is like the Z vector. So if we multiply that by, let's say we want to move it 100 millimeters, we should be able to move those. You can see that's directly shifted the plane 100 millimeters off. So that gives us a bit more room. And now, with that plane, if we decompose the plane, we can start to move things around in using the X, Y, and Z directions of that plane. So we can say, start to set out some brackets for supporting the panel. So we could say, let's move. So we can just use the original plane. We can move it. Again, it's best to unitize. That unitize means we take the vector and we convert it into length 1. So we know that when we multiply that vector by a number, so let's say we do it, let's just start with 1200. And so if we move that 1200 in there, you can see we're actually creating a new plane there. We could also do this lighter weight, would be faster, would be just to make a point like that. do the same thing here and put in an expression. Let's just do that on the screen, an expression for minus x, so we would reverse that. So now we've got points at either end. We could join those points together to make a line, and then make a pipe through there. Give that pipe a radius of, let's try 50 millimeters. And then if let's stick with shifting the entire plane. And then on each of those planes, create a rectangle with domain for, so just to give this is our x direction, so this is going to be quite small. So we do 100, set the expression here to minus x. Make a copy of that. Here it is. So possibly that's a little bit smaller in this direction, and then let's make that to 500. Okay. Possibly a little bit bigger. So the maximum is 1,000. So my panels here are around 2 meters. And then our second plane, so we can repeat this. Both ends. So we've got a simplified version. We can put a boundary surface onto there. Boundary surface on here. And so in the next video I'll look at how to export that and set up this as a detailed model study in Sketchfab.